Hi guys, today we'll talk about a math contest problem from Waterloo's grade 11 Fermat contest. This is a number theory problem with a little bit of algebra. This is question number 22 from year 2011. And the question asks, what is the number of pairs of positive integers pq with p plus q less than or equal to 100 that satisfy the equation p plus q to the power of negative 1 over p to the power of negative 1 plus q is equal to 17? So we see that P and Q have to follow some kind of relationship, right? They have to sum up to they have to both be positive integers, and their sum has to be less than or equal to 100. And we see that that expression, right? P plus Q to the power of negative 1 over P to the power of negative 1 plus Q. That also outlines the third relationship they have to satisfy. But that relationship is really hard to. It's not as straightforward as P plus Q less than or equal to 100, right? So let's first try to simplify that expression into a more straightforward relationship. So we have p plus q to the power of negative 1, right? So let's replace q to the power of negative 1 with 1 over q, because the negative exponents are kind of hard to deal with, right? Over p to the power of negative 1 becomes 1 over p plus q, and we know that this must equal to 17, right? So it's really hard to see, right, what p and q each have to be, or at least it's not very obvious. So I have a fraction, I have a fraction of fractions. So that's a little bit messy. So let's try to simplify it by moving the denominator to the other side. So the left side, we still have p plus 1 over q, the numerator, and I'll move this to the other side, so this becomes 17 times 1 over p plus q, right? And we have gotten rid of the big fraction, but we still have two smaller fractions, right, that we have to deal with. And how do we get rid of these, right? We need to first multiply both sides by a p to get rid of this fraction right here, and we also need to multiply both sides by a q to get rid of this fraction right here. So that means on both sides we have to multiply them by pq, right? So this side has to multiply by pq, this side also has to multiply by pq, right? So let's do that. P times pq becomes p squared q, right? 1 over q times pq becomes p. 17 stays. 1 over p times pq becomes q. Q times pq becomes pq squared, right? Okay. Well, actually, this expression kind of looks like this, right? So let's keep factoring to see if they actually have the same thing left. Factor out the p from here. You have p times pq, right? This is what you have left, and plus 1, right? Plus 17 times, you can factor out the q here. Q times q over q is 1. Pq squared over q is pq, right? Okay, so we see that we do have the same factor left if we take out the common factor on each of the two sides, right? So this factor and this factor can cancel out. So we have simplified this expression down to this, which is p is equal to 17q. Right? So we're looking for, in other words, looking for p and q, both are positive integers, right? Such that p plus q is less than or equal to 100, and also p has to equal to 17q. Okay, so my first question is, can q equal to 0, right? And clearly no, because q has to be strictly positive. So the minimum q can be is actually 1, right? If q is equal to 1, then p will equal to 17. Right, so 1 plus 17 also satisfies the condition that they have to less than or equal to 100. So q can equal to 1, p will have to be 17. So that works. Can q equal to 2? Right? Yes, because if q is 2, then p will equal to 34. And 2 plus 34 is also less than 100. So far, so good. Can q equal to 3? Right? If q is equal to 3, then p will have to equal to 3 times 17, which is 51. So that also works, because 3 plus 51 is way less than 100. Can q equal to 4, right? If q is equal to 4, then p would equal to 4 times 17, you have 68, right? So this also satisfies p plus q is less than 100. Can q equal to 5, right? Then p will have to equal to 85. So far, so good. As soon q is equal to 6, then p will be 102. So then it no longer satisfies the sum is less than or equal to 100. So therefore, we know that q can equal to 1 all the way until 5. And for each of the values of q, you can find a P that corresponds to the value of Q. So therefore, we have 5 such pairs.